So our next speaker, Bhuvnesh Sharma, for the talk Anatomy of Django Migrations. Okay, mic over to him.
Okay, so hi everyone. Uh, I assume if you are here, you must have used Django in your day-to-day task at some point. But still, I'm going to ask how many of you are Django users? Maybe you are learning or have used. Okay, great. So today's talk will be on Django migrations. So add field, pray, migrate, and repeat. I'm sure everyone can relate to those four words. A little bit about me. I'm a Django core contributor. In I'm also a Google Summer of Code 2023 mentee. In 2024, I was a mentor, and this year I'm an org admin with Django Software Foundation. And I'm also co-chair at social media working group at Django Software Foundation. And if you know about Django India community, I started that community around a year ago. And in Django, like I have mainly contributed around migrations framework, some of the tickets around ORM, and yeah, a few minor contributions. So one day I was asked to do some field changes to my database, and I went on to write some manual SQL query for it. And after a few minutes, everything was fine. So raise your hands if you have ever feared the schema changes, like applying schema changes. Everyone is really scared of it. But why schema changes hurt? So schema changes are really painful because while your application code evolves quickly, your database might lag behind. And manual SQL is brittle and error prone. And just one small typo can destroy your production. So let's see how Django handles the schema changes. So whenever you make any changes to your database models, and all you need to do is run python manage.py make migrations command followed by python manage.py migrate. And just like that, your database stays perfectly in sync with your code. It's magical, right? So what we'll cover in this talk, we'll see how migrations work in Django and what powers them behind the scenes and why you should care even if you use Flask or Fast API. So this is the typical flow that a Django user has to go through while making any database related changes. So first, they do any changes in their models, then they run make migrations command, which generates a migration file or multiple migration files. Then when migration command is executed, the changes inside the migration files are safely applied to the database. So all of this can be seen by the user, but now let's have a look at what users don't see. Yes. So these are all the components that take part in the complete, operation of generating and applying migrations safely to your database. We'll not be going through all of it in this talk, but we'll definitely look at some of the key components and try to derive a simplified version of this diagram. So let's start with model state, app state, and project state. So model state represents the definition of a single model at a specific point in time, which includes its fields, relationships, options, and other constraints. These are like a lightweight version of your actual models that are there in your database files, and all these model states come together and they form an app state, which captures the state of an entire Django application, encompassing its models, migrations, and all the dependencies. So at the highest level sits the project states, which reflects the overall configuration of a project at a given moment, combining all the apps, their migrations, and setting it into a unified snapshot at a particular point. So moving forward, we'll have a look at what are migrations actually and the operations. So operations are like fundamental steps that tells Django how the database schema should evolve over the time. They look at an instance of a project state and then they try to mutate the model states that are in the project state. So a migration file is, essentially it's a collection of multiple operations, each operation representing a change in the database, such as maybe creating a model or adding a field, altering a field, or something like that. So together, migrations work like a version control for your database, and it records every schema change, so your database always stay in sync with your code. So now that we know how migration system, like migration keeps track of the state, how to mutate the state and talk to the database. Let's have a look at uh, how the project state, like how the changes between the project state are detected. But before that, we'll have a look at the actual migration file. I'm not sure if it's fully visible. Let me see if I can zoom it. Yeah, so a migration file looks like it's this. So you have a few imports, then you have a migration class, you have some dependencies which tells Django which the order in which the migrations should be applied, and then you have few operations. So these are the operations like create model, altering a field, and like this is the actual migration file. Okay, so moving forward, so autodetector is one of the component of migration framework that works by comparing the project state with the old one. So let's say uh, you have a Django application. So what Django will do, it will create a project state from the existing migrations, and it will create another project state with the uh, current database, like current code of your Django, and it figures out exact set of database operations that are required. And yeah, so let's have a look at what is the difference between a model state and an actual model. So a model state in Django is a static serializable snapshot which is used exclusively by the migration system, and it holds only the bare metadata of a model, such as its name, field, options, and base classes, and it can represent any historical version of that model, making it like very useful for comparison. On the other hand, a model class in Django is like a live ORM representation used at runtime for querying and saving the data. So unlike the migration state, it contains the full Python logic, which includes methods, managers, and it always reflects your current state of the code. And after like doing an in-depth research and sacrificing my sleep for few nights, I created a diagram which will help us understand how migration framework actually interprets model state versus the actual model. So let's have a look at it. Yeah, so it looks something like that. So I hope this gives you a complete understanding of how migration interprets model state. Okay, so I have a question. So can anybody tell me what happens when we try to add a non-null field without a default in Django? Exactly. Yes, that's correct. So let's say there was a patient model, you have a field, you already have a field called name, and then you try to add a field called age, which is an integer field, and it is not null, and it doesn't even have a default. So what Django will do, it will prompt you, and it will not allow you to create migrations. It will say that it's not possible to add a not null field without a default because it needs something to populate its existing rows. Moving forward, so we have, so this, all this process is handled by the component called questionnaire. So questionnaire engages the developer during make migrations or migrate command, asking for input whenever there are, you know, ambiguous changes or that anything that is unclear to the to the framework. And questionnaire is executed by autodetector just before generating the migration operations. So in my early days when I was learning Django, when I first encountered this questionnaire, I was little confused because obviously I was not aware. So uh, my reaction was something like this, because it is just a new field. Why are you asking me for default? Then I came to know that okay, this is risky. Okay, so we'll have a quick revision of what all we have seen so far. So we have an understanding of what is project state. We know what is app state. We know what is model state. Then we had a look at operations. We had a look at migrations, and we know how migration operations are, generated by autodetector, and we know how unambiguous changes are handled by migrations framework. So I'll just give you 10 seconds. So let that sink in. I'll just have some water. Okay, so things are going to get a little difficult now. Okay, so migration graph. So Django organizes migration files as a directed acyclic graph where each node represents a migration file and each edge represents dependencies between them. I'll explain what does that mean. The framework uses a depth first search algorithm on this graph to determine the correct order in which the migration should be applied, ensuring all the dependencies are resolved and the database schema changes are, updated safely. So let's so what I did, I created a Django app called Cars. So it had 3 migrations, and after that I created another app called Tires, which had 2 migrations. And out of curiosity, I tried to uh, get the migration graph of these applications. So it looked something like this. So this was the graph that was generated using a Python package called Django Migrations Graph. So you can probably even tell which migration file is dependent on which other migration, and the order in which these migrations will run will be we'll be using a DFS algorithm. So it will, I mean, I'm not sure if everyone knows DFS, but you can definitely explore. So moving on to the next slide, let's have a look at what will be the order of migration, like applying migration. So it will go to the last migration first, which will be car 001. Then it will apply tires 001. After that, it will go to cars 002. Then it will go to tire 002, and in the end it will apply car 003. Now if we try to understand this using graph, so depth first search works like it will go from it will in the first iteration it will go to the last node and it will check if it's applied, then it will come back, then it's going to get tires, and in the same fashion it's going to apply all the migrations. Okay. Yeah, so now let's have a look at how graphs make migrations reliable at scale. So migration graphs ensure reliability at scale by tracking dependencies, which guarantees that migration runs in the correct order while respecting the model relationships. It prevents conflict by detecting when multiple migrations modify the same dependency. It by merging changes or issuing warnings as needed. Additionally, it supports branching, allowing parallel migrations work from multiple developers to be safely merged without breaking your project. And the migration graph also detects missing or duplicate migrations, preventing accidental skips or reapplications. It enables partial app migrations, allowing targeted migrations runs for specific app without affecting others. Last but not the least, it supports reversibility, maintaining a clear and safe path for rolling back changes whenever you need them. So these are all the features of migration graphs that ensures flexible and conflict-free migrations. Now let's have a look at the components that helps in building this graph. So one of them is loader. So loader reads migration files from disk and constructs the in-memory migration graph. This graph represents the relationship and dependencies between migrations, allowing Django to plan and execute them in the correct order and in an efficient way. So we have an executor. So executor take the migration plans built by the loader and then it run them, applying or unapplying migration as needed to bring database schema in sync with the desired state. So here we have a simplified version of what we saw earlier. So if I try to explain this diagram, so you have a model state, then multiple model states form app state, multiple app states form a project state, and then that project is loaded in the executor, and a graph is created on the basis of the project state, like the old project state and new project state, and all of it is then combined to a common class called migration, and then that migration class loads a few other components like executor and stuff, which helps to execute those operations on the actual database. So yeah, congratulations, now you know 20% of the migrations framework. So talking about a little bit of history of the Django migrations. So it was created by Andrew Godwin, and before migrations came into picture, it was around Django 1.7 release. So before that, developers used to use a tool called South to manage their schema changes, and South was also created by Andrew Godwin, and later it was merged into Django core, and original PR, you can check out hashtag 376. It had around 6,000 line of changes, and there were significant improvements that were made by Marcus Holterman. He was one of the earliest contributors in of the migration framework, and he authored a few command like show migrations command. He also worked on feature for generating migrations for models with multiple inheritance. So yeah, now 20.1%. So now let's have a look at why migrations matter beyond Django. So migration keeps our database schema safe and consistent as we make changes step by step. They are idempotent, meaning you can run them again without breaking or duplicating the data. and they make the teamwork easier since multiple developers can update the schema in parallel without running into conflicts. Okay. Yeah. So yeah, you can support Django Software Foundation as well. So you can contribute to DSF. You can help sustain Django's development. You can fund community initiative, and you can ensure that framework continues to, grow and it remains secure and supports the developers worldwide. So this is like the page where you can support Django Software Foundation. Yeah, so these are all the resources that were used to, create the slides. Yeah, thank you. Thank you very much. So if anyone has any questions, can feel free to ask. Yeah. Other database stuff. So
Should I repeat? I'll just repeat so that everyone can hear.
yeah, sure.
Can you speak a little about how Django migrations work for views and stored procedures, other stuff than just tables?
Okay, so if you want to, use views and stored procedures and stuff, so there is a functionality of, running manual SQL basically. So there doesn't have any inbuilt functionality for views and stuff. So they have an operation called run Python, if I remember correctly. So these are like the manual migration files. You create a empty migration file and then you add the run Python features. And if you want more flexibility, like for applying and not applying, so there are methods called migrate forward and migrate backward. So you can use them as well. Yeah. Any other questions?
Hey, thanks for the here in the front row.
Oh, yes, sorry.
Thanks for the 20%. I'm looking forward to the next 80% in your next talk.
I mean, it's a huge concept. So, I mean, it's difficult to explain all of it in 30 minutes talk.
Yeah, no, thank you so much, though. There's one problem that I've always encountered with Django migrations in production, which
Okay.
is when you have a large enough database, the migration itself can take like multiple minutes to
Okay.
run, and then but you can't have downtime during that time. Like you can't bring your site down. So
Okay.
I'm wondering if you have any tricks for like application code that's running that's either deployed and depends on the migration to be run successfully, but like there's some the migration can take like 5 minutes if you have like over 100 million rows. So do you have any tricks for it?
Like, there might be some tricks, but I'm not aware of any such trick right now. So if you have a huge database, I mean, even if you run like manual SQL or something, it's going to definitely take a lot of time. So yeah,
Okay. Thank you.
thanks.
Yeah, thanks for the talk. My
Thanks.
question is that how do we use Django migration when, let's say, we have schemas separate for separate tenants, but I mean, all of them share a common database, but they have separate schemas.
So you can use a library called Django tenants, and it's going to handle most of the stuff for you. So when you are like applying database changes or you are using the different tenants, so Django tenants has the functionality to uh, you know uh, pass the schema which you want to use. So you can definitely explore Django tenants library, and it will be like very helpful for you.
The last question.
Yeah.
So just something that I like thought of when I saw the slides. So you mentioned that the questioner will ask you what the default should be.
Yes.
Now that doesn't go into the code anywhere.
No.
That's a runtime thing.
Yes.
Now, how do you communicate that to another team member without just telling them, okay, just when this comes, type in X or Y or whatever is the default? Is there any programmatic way to communicate that, like just git clone this, it will ask you what the default should be, it should be this. It should happen in the code. I should not be like telling that on a separate channel.
Uh, what? Sorry? Yeah, I mean, if you are setting the default in the prompt, it it will generate the migration file with those values.
Okay.
Yeah, so you don't have to worry about that.